Hi, in this video I'll teach you some properties of definite integral and focus will be on the linearity. So these are how integral works with the integrand, sum, constant, multiple, and difference. Well, let f and g be integrable functions on the interval AB. Then when you have integral of sums of these two functions from A to B, integral works nicely with addition. In other words, integral of sum is a sum of integrals. And the same bounds. The second thing is that, well, the same thing works for the differences. And, well, this is just AB f of x minus gx. Oh, sorry, the difference of the integral. AB minus. Okay, this one. Also, there is a third property, which is, well, if you multiply function by a constant, c is a constant. In that case, the constant comes out from the integral, and that gives us what we have. Well, the reason that these properties hold because of the similar properties for sum. Remember that integral of AB f of x plus gx dx is going to be limit of n goes to infinity sum of delta x. Here f of xi star, any sample point, plus gxi star. I goes from 1 to infinity, 1 to n, sorry. We have n subintervals. And then you see that this guy is, you can separate these guys. And write it as two sums. I equals to 1 to n. And this is one of the properties of sigma notation. And well, from there, since f and g are integrable, you see that this piece has a limit, this piece has a limit. So limit of sum is sums of limits. And this way, what we find is very nice proof of what we saw just up there. The first part is the integral of f of x dx from a to b, and the second one is an integral of gx dx a to b. Well, the same proof goes if this is minus there, this will be minus. How about constant multiple? Well, this is the same story as we just saw. If c is constant, this will be limit of sum of delta x. The function is c times f of xi stars. I goes from 1 to n, and n goes to infinity. This limit, since this is constant, this can come out. I going from 1 to n. And since this is limit, you remember what we call constant multiple law. So this will give you c of limit, but that limit is nothing but the function dx. So these three properties are called the linearity of integral. Integral is linear with respect to its integrand. Well, let's see some examples for these properties. Okay, here, well, we have 2 times x plus 1. I can separate these guys first using the additive property, and then there's a constant. I can put that out. X dx plus integral of 1 dx. Well, you may say that, okay, I could have done this from the beginning, but in some cases, yes, this is just more practice kind of thing. But in more cases, separating will be very helpful, as we will see in the second example. But when you get to this point, now you can use the areas. Remember, this is the graph of the first one is this guy, x from -1 to 3. So it has 2 p's, positive, negative. And the other one is just constant 1 from -1 to 3. So this is -1, this is 3. This is just a rectangle. That's 2 triangles. Here I have 2 times the area of the small triangle. So here this is 1 times 1 over 2. But since this is in the negative side, we have to put minus there, plus area of the bigger one. So this is 3 times 3 over 2. What does that give us is, oh, this is just first piece, sorry. Then there is another piece plus 1 here. This is just a rectangle there, yes? With height is 1, the width is 4. Now you do this computation. This is -1 plus 9 plus 4. And that all together gives us 12. How about this other one? Okay, so the graph of this guy itself is not easy to sketch, but if we use the properties and write this as 2x dx integral of 0 to 4 3 root 16 minus x squared dx, then we can bring out the constants. So integral 0 to 4x dx plus 3 integral of 0 4 root 16 minus x squared dx. Now here you have 2 functions. One is the function y equal to x. So I have this guy from 0 to 4. The other one, this guy is a semicircle, but since we are taking from 0 to 4, this is a quarter of a circle. This is 4, so we know how to find the areas of those guys. You see, this will be 2 times 4 here, 4 there, so 4 times 4 divided by 2. Plus 3. This is a quarter of a circle, so 1/4 of pi. R is 4, and that will give us what, 16 plus 12 pi, and that's what we have. Sometimes we may get questions like this. Okay, so I don't know what is f, I don't know what is g, I only know what are the definite integrals of this function from 2 to 3. So we can first separate them, additivity. Then we can bring out the constant multiple. Oh, this is 2 to 3. And now that we are here, we know that the integral of f of x from 2 to 3 is 5. plus 4 times integral of gx from 2 to 3 is negative 2. This is 10 minus 8, which is this other one. So we get minus gx 2, 3 dx plus integral of 3 dx 2 to 3. This minus sign is negative 1 times that, so it can come out. And 3 can come out. And what we have here is just negative integral of gx is negative 2 plus 3 times. This is the area of this rectangle from 2 to 3. Height 1. Actually, it's circle. This is 2, 3. This is 1. This is 1. So this area of that. So this will give us 2 plus 3 times 1, which is equal to 5. So you have to be able to apply these properties and break down the integral to smaller pieces that you can evaluate and then add them at the end and get the final result.